Okay, Algebra 1, welcome back. Again, we're still in our quadratics unit after a week off for spring break. And today we're going to talk about the third and the final form of quadratic functions. Yeah. So just a reminder, we already talked about standard form, which is ax squared plus bx plus c. Okay. Standard form had formulas to find the vertex. The y-intercept was c. We were able to find a lot of information from standard form. Factored form was a times x minus p times x minus q. Okay. Factored form helped us find the x-intercepts, okay, using zero product property. The last form we're talking about is vertex form. And as the name implies, vertex form is going to help us find the vertex. Now, unfortunately, vertex form pretty much only helps us find the vertex. But again, the vertex is probably the most important part of a quadratic. All right, so vertex form is f of x equals a times x minus h squared plus k. Okay. So these are all three forms of the quadratics that we're going to be working with and we've been working with. Now, one thing to notice is that all of them have the a value. That a value is going to be the same in every single form. So you could write every quadratic function in standard form, in factored form, and in vertex form, and they're all going to have the same a value. Okay. Now, all the other letters are different. All the other variables represent different things, but that a value is always the same. And remember what a tells us. It tells us if it opens up or down. It tells us if there's a min or a max. It helps us find the range. And that's always going to be the same. All right, so what's this h and this k? Okay. Well, like I said, vertex form helps us find the vertex. So where is the vertex if you're in this form? Okay. Well, that's where the h and the k come in. Okay. So in vertex form, hk is going to be the vertex. Now, if you remember from, about 10 days ago, factored form had these minus signs already in it. Okay. So in factored form, our intercepts were always the opposite of what we saw. It's the same thing with the h value here. Okay. That h value is always minus. So if you see a plus there, that means your h is negative, and if you see a minus, it means your h is positive. So it's always the opposite of what you see inside the parentheses, and then whatever you see on the outside. So the plus k is just going to be k. Okay. Well, remember, if we know the vertex, then we automatically know the axis of symmetry. Okay. It's always the x value of the vertex. So x equals h is going to be the axis of symmetry. AOS. And the y value of the vertex always tells us the min or the max. Okay. So that k value is always going to be the highest point or the lowest point. All right, and that's pretty much everything that it tells us. Again, you could always find the y-intercept by plugging in 0 for x, but it's not some quick formula like it is in standard form or like in even factored form where it's just a times p times q. But again, you could do that for any function. If you want to find the y-intercept, plug in 0 for x. All right, so let's look at some examples then. And hopefully this will all fall into place. So let's say we have the function f of x equals 1/2 times x plus 3, the whole thing squared, minus 2. Okay. All right, so that is in vertex form. Remember what vertex form is. We just wrote down. It's the a value times x minus the h value squared plus k. So we should be able to identify what a is, what h is, and what k is from just looking at vertex form. Well, obviously a is going to be 1/2. Again, what does that tell us? Well, since a is positive, it means it's going to open up, which also means it automatically is going to have a minimum. The h value, now again, the h value in the formula is x minus h, but we have x plus h. So how do you make a minus become a plus? Well, it has to be minus a negative. So your h value isn't 3, it's negative 3. Okay, it's always the opposite for the inside number. And then your k value in the formula is plus k, but we have minus k, or we have minus 2. So your k value is negative 2. So always, it's the opposite for the inside of the parentheses, and it's just whatever's outside. It's the same for factored form. Whatever's inside those parentheses, our answer was always opposite. All right, so that's what a, h, and k are. So what is our vertex? Well, the vertex is always h comma k. H is negative 3, k is negative 2, so negative 3, negative 2. Well, what's the axis of symmetry? Again, the axis of symmetry is always the x value of the vertex. Or in this case, it's always the h value. So our axis of symmetry is the line x equals negative 3. All right. The opening. Well, we already mentioned it. A is positive, so this is automatically going to open up. If A is negative, it automatically opens down. If it's positive, it automatically opens up. It's always the case. All right, so what's our min or our max? Well, again, since this parabola, and we're not going to graph it today, but since this parabola opens up, it's going to be like that. The vertex is going to be the lowest point. Okay. So we're going to have a minimum at whatever the y value of the vertex is. A minimum at in this case, at negative 2. Okay, that's going to be the lowest point on the graph, the lowest y value on the graph. What else can we say? We could do the domain and range. Remember, the domain for all these quadratics, unless it's a word problem, is always going to be all real numbers. Okay. So you type fancy R, you could just, I know in the Google Forms, you could just type in all real numbers. You go negative infinity to infinity, however you want to write it. Now the range depends on if it opens up or down. It depends on if there's a min or a max. In this case, there's a minimum at negative 2. Okay. What that means is that every single y value is going to be bigger than negative 2. Or rather, every y value is going to be greater than or equal to negative 2, because that's the lowest point on the graph. Okay. All right, so that's everything that vertex form tells us. Okay. Now again, we didn't get a y-intercept, we didn't get any x-intercept, so we don't really have that many points, but it does tell us a lot of information. Okay. All right, let's do one more. This time, let's say we have f of x equals, let's go negative 3 times x minus 5 squared plus 12. All right, now again, identify what a, b, or what a, h, and k are. A is always in front. In this case, it's negative 3. H is always inside, and it's always the opposite of what we see. So we see minus 5, which means our h value is positive 5. And the k value is always at the end, and if it's outside the parentheses, it's always just whatever you see. So we see a plus 12, So our k value is positive 12. All right, once you know that, you automatically know the vertex. And you automatically know the axis of symmetry. And we automatically know the opening. We know the domain. We know the range. We know the min or the max. And on this one, let's find the y-intercept. Okay. So this is all information we could get by just knowing A, H, and K. Okay. All right, well, what's the vertex? The vertex is always H comma K. H is 5, K is 12, so the vertex is 5, 12. Axis of symmetry. Always x equals the x value of the vertex. So x equals 5, or in x equals h in vertex form. The opening. Opening depends on the a value. Our a value is negative. It's negative 3, so this one's going to open down. Okay. Again, why? It's because a is less than 0. A is negative. The domain, again, all quadratics, all functions that we do in Algebra 1, it's going to have all real numbers. You can plug any x value in and you're going to get a y value out. The range, okay, now maybe I should have done min or max first. Since our parabola opens down, okay, the graph is going to look something like this. It's going to be opens down, which means your vertex is going to be the highest point. So this graph is going to have a maximum. And where's the maximum at? Well, the maximum is always at the y value of the vertex. So 12 is going to be the highest point. Which means for the range, all your other y values are going to be less than 12. So translate that into symbols, y values are always going to be less than or equal to 12. And then find the y-intercept. To find the y-intercept, we always plug in 0 for x. So we're going to be finding f of 0, and that's going to be our y-intercept. So we got negative 3 times 0 minus 5 squared plus 12. And then just evaluate that. That's negative 3 times negative 5 squared plus 12. It's going to be negative 3 times 25 plus 12. Negative 75 plus 12 gives you a value of negative 63. Good. So good thing we're not graphing that. So that's our y-intercept. Again, just plugging in 0 for x. All right, so again, recap vertex form. It is a times x minus h squared plus k. Okay. The vertex is always the x value is always the opposite of what you see. So you see minus h, it's positive h. You see plus 5, it's minus 5. And the k value is always whatever you see. So h comma k is the vertex. And then from there, we can find all this information that we've been finding for the past couple weeks. All right, check Google Classroom for the assignment. Have a great day.